Hi there, I'm John from CNCKing.com, and today we'll make a CNC routered and laser engraved HDPE mold. So the way we produce what you see here is using our CNC router and our laser. Let me show you the routering part. So basically this is HDPE. It's almost an inch thick. And the customer needs this to be produced as a solid piece. This is another prototype in order to produce their product. So basically this is a mold of a mold of a mold. Why they do that, I don't quite understand. But for their process, that's what they need to have done. And that's what our job is to produce. So there's two issues with this. The biggest issue is we have a laser, but the laser cannot accurately cut through this much HDPE cost effectively. Or at the resolution that our CNC router can. Now on the opposite side, the details that are laser engraved into here cannot be done with a router bit because they're too fine. So basically you're stuck between two machines to produce one product, which is fine. That's the nice thing about having multiple machines to do something. And as a result, we use a CNC router to basically produce the blank that you see here, without the laser, without the engraving of course. And then we put this into the laser and zero everything all over again, and then do the laser engraving onto the HDPE. The advantage of this process is obviously we're not going to break any bits, because the smallest bit we would need for this is probably 1/32 bit to produce some of these details. And our router can accept those kind of bits, but I don't know of a material that lasts long enough to make it worthwhile, because those bits are exponentially easy to break. They just don't have any strength to them. So you're going either incredibly slow and you're still breaking the bit somehow, or you just use a different machine to produce something that's clear. Now the nice thing about the laser is there's no bits involved. The bad thing about the laser is that there's some details that cannot be produced with the laser that must be done with the router. So for instance, you have a bevel along the edge here. You can't do that with HDPE using the laser. So again, it's a mismatch of two different machine processes to produce one product. So when it comes to using a router on plastics like this, one of the most common issues that I actually have is not actually cutting it. It's actually all the flakes. As you can see, there's flakes everywhere. You get the same thing with Cori, and you get the same thing with a lot of different plastics. And the problem with that is that it just gets absolutely everywhere. And because of the process that you're using to cut it, there's a lot of static electricity in it as well. So it just sticks to everything as well, including the rails that you see right there, and the tooling and everything. So one way around that is to have a good suction system, which I have. But because I'm filming this, I have to actually turn that down a bit, and I have to use, as you can see, the head for the vacuum system is a little bit higher because I want to show actually what's happening. So normally during production, that's the difference. During production, I'd actually have this completely covered and I wouldn't have these flakes all over the shop. But when I'm filming, I need to do that. Now the next step after using the router, I use two different tools to produce this. One to sort of carve out the hole, and the other one is to produce the outline that you see, the smooth outline. After that, I reposition things into my laser. Now the laser and the router both have the same tolerances, the same sort of precision in the tool itself. So that means I can easily switch from one tool to the next to the next. Same goes with the plasma, milling machine, everything. So that's very convenient for a project like this, because you can see the details inside of here are just not possible with the router bit. The router bit, I guess you'd have to use like a 1/32 or 1/64 bit. That's going to break almost immediately. There's just no strength to it for something that fine in this kind of material. But you'll notice that what the laser does, it produces smoke. So that's another issue that you need to contend with, and that just goes through the filtration systems and outside. While with the router, you're producing chips. So I did a video a little bit earlier showing you basically the same mold. This was all laser engraved and cut using our laser, and this is the composite mold. Now the nice thing about this falls on the ground, no problem. HDPE, you can throw it from an airplane, it'll fall on the sidewalk, no damage to it. Acrylic will shatter in a billion pieces on you. So I guess there's that. So the process that the customer is going to be using, We're going to prototype it, and we'll see, based on their feedback, how it works out. But, that's the kind of company I like running. I like having these challenges because the customer just could not find anybody who could do this kind of stuff. You have the problem where you need really both machines to do the one process. Because if you don't have both machines, you can do half a job and then you have to stop, or you do the other half of the job, you have to, there's no in between that you can achieve. So looking for custom routering or lasering or metalwork or whatever, contact me at CNCKing.com. We make it for you and ship it right to your door.